When we're working with electric circuits, one thing we'll need to do frequently is use meters to make measurements. And we can make measurements of resistance, we can make measurements of voltage, and we can make measurements of current. The resistance meters that we've used before, we've used those in class, and you just put one end on each end of the meter on each end of the resistor. Pretty straightforward to measure. But voltmeters and ammeters, which measure current, are a little bit more complex. We have to be a little more careful with how we set those up. So let's say we have a circuit, and how about it's a parallel circuit, and we want to measure how much current is going through one branch of this circuit. So we have current that's leaving the battery, and it splits off into these two paths, and it's going to break up in some fashion. We want to know, say, how much current is going through this branch. Well, if we want to know the current going through this resistor, we need to put an ammeter in there. And how do we connect the ammeter? Can we just say put an ammeter like this? Oops. And the symbol for an ammeter is just an A with a circle around it. Well, no, we can't, because to measure the current, we need the current going through the meter itself. We can't measure the current going through the resistor. We have to measure the current going through the meter. And here we have this split off here, and so we'd have some amount of current going through the resistor and some amount of current going through the ammeter. So we wouldn't be measuring how much is going through the resistor. We'd be measuring some separate value. So that wouldn't be useful to us. So it turns out that ammeters have to be placed in series with the component that we're trying to measure the current through. So we need to disconnect a wire there and put our ammeter right in line with that resistor in order to measure the current going through this section, so current I. Now, that value is determined. How much current is going through that section is determined by the total resistance of this path and the total resistance of this path. Now, if we include this ammeter and it has a really high resistance, then less current is going to go through this circuit than, or this path, this branch, than would go through this path. And so in order to make this ammeter not change the way that current is flowing in this circuit, we have to have our ammeters have very low resistance. So very low resistance, and we put them in series with the component that we're trying to measure. Okay, now voltmeters, let's say we have now a series circuit, and we want to know, what the voltage across this resistor is. And that's a good way to phrase it, across the resistor, because it helps us to remember how we set up the voltmeters. So if I, say, put my voltmeter in right here, just a V with a circle in it, that's not going to measure the voltage across this resistor. How could we measure the voltage across the resistor when there's no connection to the other side of this resistor? That doesn't make any sense. So our voltmeters, we need to measure, have some connection to each side of the resistor. So we'll put our voltmeter in parallel with that resistor. Now, with our voltmeter, we want our current to still flow the same way around this circuit. So before we put the voltmeter in, it went through this resistor, and then through this resistor, and then through this resistor. We don't want our current to be splitting up and traveling along these two paths, or we don't want a significant amount of current to travel through this voltmeter. So in order to make that not happen, we have very high resistances on the voltmeters. So a little bit of current passes through here, but not very much. It's almost all going through this resistor. And so our voltmeters have very high resistance, again, so that we don't change the way that our circuit operates, and they're put in parallel with the component. Now you want to be really careful to set this up well. You can actually ruin a meter, or at the very least burn out a fuse on a meter if you're not very careful in this. So if you think about a circuit like this, say that just has one resistor, and we want to know the current through here, if we were to accidentally put our ammeter in parallel with that resistor, say this is a 5-volt battery here and maybe a 1,000 ohm resistor, we'd have originally our current just passing through this 1,000 ohm resistor, but if we plug in our ammeter in the wrong fashion like this, we put it in parallel instead of in series, the ammeter, remember, has very, very low resistance. And so most of the current is not going to travel through this 1,000 ohm resistor, it's going to travel through the ammeter. Now if our ammeter has a resistance, say, of 0.001 ohms, something very, very low, then the current going through that, current is equal to voltage over resistance, that'd be 5,000 amps. That's a huge amount of current, and so yeah, that's not going to do anything good to our ammeter. Not only that, but we wouldn't be measuring the current that's going through this resistor, we'd be measuring the current that's going around that resistor. And so, in this case, that wouldn't be a huge deal, but if, say, we put our ammeter around like this, we're not measuring the correct current there, not to mention the fact that it's, dangerous to our meter, but we aren't going to get a correct value for that to begin with. So you got to be careful with these. Voltmeters are high resistance. We put them in parallel with our component, like this one is. Ammeters, they're very low resistance, and we put them in series with the component that we're trying to measure.